Today we are going to do a master deployment, and it's a DevOps end-to-end life cycle. And we have a sample project which I am going to demo that project in our repository. And I will also share the link to that project, and you can also find that project in our repository to follow along if you're interested to implement that project. If you go to our repository in our organization, the project is called Hilltop EKS project. This is the repository. And within the repository, we have a README file that summarizes a few steps. So in the README file, we are going to clone the repository. And after cloning the repository, we'll cd into a folder called Jenkins. So within that folder, we are going to see that folder clearly when we clone the repository. And in the Jenkins folder, you initialize Terraform. It's a Terraform configuration file. So you initialize the Terraform configuration file, and then you apply it. So we're going to see the content of that file. So after Terraform is initialized and it's applied, it's going to create an EC2. It's going to deploy an EC2 instance, and the same script is also going to deploy Jenkins. In that, there's a jenkins.sh file. And in that jenkins.sh file, it's for user data. So it's going to deploy Docker, deploy Jenkins, deploy Kubernetes inside the EC2 instance that Terraform is going to create. So when the EC2 instance is coming up, it's going to bootstrap all this data found in this jenkins.sh file. So when the instance is up, we copy the public IP address and port 8080, and we should be able to access the Jenkins server. Within the Jenkins server, we are going to log into Jenkins and go to Manage Jenkins. We add our AWS credentials and our Docker credentials. And then in the pipeline, we are expected to clone the Docker repository in the pipeline, build our application. So this is the source code for the application. All these files contain the source code for the application. We build, we push the image to our Docker Hub repository. All of this happening in our Jenkins pipeline. And then within the Jenkins pipeline, we create an EKS cluster. And after creating the EKS cluster, we deploy an application on the Jenkins pipeline. And this application is also going to deploy a load balancer. And with the load balancer, the moment we copy the load balancer URL and we can successfully access our application on the browser, then it means the deployment is successful. Okay. So we're going to use a load balancer to access our application. At that point, our deployment is successful, and that will be the end of our project. So we copy the URL for the repository, and on VS Code, I'm going to create a folder on my desktop called project so that we clone into it. So I've created a folder called project, and on VS Code, I want to open a new folder on a new window. Sorry, I'm opening a new window so I can close this existing window. Now we have a fresh window, and on that window, I want to open a folder, or I want to clone a repository, right? I want to clone a repository. Clone repository, so I can paste the repository URL here, and I hit enter. So I'm cloning into my desktop and into project. So I'm cloning the repository into project. Would you like to open the clone repository? Yes. So this is our repository, and I'm going to go through the files and explain according to what we have in the README file. So the first step is we have this Jenkins folder. In the Jenkins folder, we have EKS Terraform configuration files. The first Terraform configuration file is the instance.tf. In the instance.tf, we define a resource block where it defines our EC2 instance, the AMI, the instance type, the key pair, the subnet ID, VPC security group ID, and all of this. And look at the user data. The user data is found in jenkins.sh. So our user data is going to be jenkins.sh. Now we have the main.tf. This is the main.tf that simply defines a few configuration files as well for the AMI. So it's going to filter for the latest AMI in that region. And we also have output.tf. The output.tf, we want it to print our public IP. So the moment Terraform finishes creating this configuration, we should be able to copy our public IP address. We have provider.tf. So our provider, we can choose a region. So this region is US East 1. So in our AWS console, we can decide to change region. So this is our AWS console. What region do you propose we use? Let's say we go for EU Central 1, okay? Let's change region. EU Central 1. So if we come back to our Terraform configuration files, in our Terraform configuration file, let's use EU Central 1. So EU Central 1. To be sure that we have changed EU Central 1 wherever there is need to change EU Central 1, what is easier to do is I can copy what was previously here and I go to here and I search. So I search for this. Can you see all the files? It appeared in 3 spots. Okay, EU Central 1A. So I want to change this to use US East 1. Sorry, this is US East 1. I want to replace wherever I see US East 1. I want to replace it with EU Central 1. Like this. So if I click here, replace all, it assures me all my files have been replaced. So it's an easy way to do changes. So we have security group also. This is the security group. And if you see our security group for Jenkins server, we are opening port 8080, which is the port Jenkins should run on, right? We are opening port 8080 for Jenkins to run on. Then terraform.tf. Here, the name of our key is called key, okay? The name of this key is called key. So we need to make sure that we create this key. We need to make sure we create this key in that region. Do we have this key in that region, EU Central 1? Let's switch to EU Central 1, Frankfurt, and find out if we have that key existing. To know that, I simply go to EC2 and I go to key pairs. We have one key and it's called key, but I'm not sure it's the same key. So I'll just delete this one and we create a new key. So I've deleted this. Let's create a new key pair and let's call that key Jenkins. Jenkins key. For example, Jenkins key .pem. So I'm downloading this key to my desktop. Jenkins key. Jenkins key.pem already exists. Do you want to replace? Okay, yes. So I've replaced this. I have a Jenkins key on my desktop. So back to our configuration, we also need to make sure that wherever this key is being used, we replace it with Jenkins key. So I search for key. Now I'm searching for key. And I want just key.pem, not all the keys. This is, no, I think we use this key just once. So this should just be one. You don't need to replace. So it should be Jenkins key. Jenkins key, this is okay. Jenkins key and variables. These are all our variables being used. And for the VPC, this is our VPC, subnet 1, So the configuration to create the EC2 instance looks okay. Now, the most important thing is this Jenkins.sh. Because we want this instance, at the moment of creation, we want it to run this script. What is this script doing? This script is installing Jenkins. So this part is going to install Java and Jenkins. Same normal thing we do. It installs Git here. After installing Git, it also installs Terraform. After installing Terraform, we also install kubectl. After installing kubectl, we install Docker. So this is Docker, kubectl, Terraform, Git, Jenkins, and Java. So all of this is going to be installed on our EC2 instance. Okay, so we have done our changes, and I want to commit these changes to our repository. So I commit this, and I sync changes. So if you look on our repository, we expect in our repository to see that if you go to Jenkins, the configuration should have changed. Okay, we have changed a few things. This is the user data script jenkins.sh. I want to make sure that the key has been changed. EU Central 1. Okay, EU Central 1. So everything looks okay. Jenkins key. Yeah, now we use Jenkins key. The availability zone is EU Central 1A, where it is going to be created. This is good. So we are going to proceed with that. And so what we do is we initialize Terraform, and then we deploy. So we're inside our project, ls. So we cd into Jenkins, because this is the folder containing the resource we want to create. ls, this is it, jenkins.sh, instance, and all of that. So we do Terraform init. Request bucket EU Central 1. Have we spelled something wrongly? Actual location EU West 1. Okay, this bucket is found in another region. So we need to create this bucket back. Providers, this bucket, top bucket. We need to create this S3 bucket for our backend. So here, okay. So in our AWS, we need to create this bucket, S3 bucket. We have this bucket existing, but it's existing in a different region. Okay, so we need to create this bucket in this region as well, create bucket. And this is the name of the bucket in a different region. Everything, we leave it as default, and we create bucket. I can delete this. The top app bucket. Bucket is not empty, empty bucket. So we need to empty our bucket before we can delete the bucket. So we create the bucket back in this region. So when we initialized Terraform found the bucket, but said that bucket was in a different region other than EU Central 1. So we need to make sure that Terraform finds the bucket in the right region. GitHub app bucket. Unexpected error. Okay, let me just change it to this. GitHub bucket. So we're going to use GitHub bucket rather. So this is the name of our bucket. And we change this to GitHub bucket. Like this. So I want to make sure that we always save our changes. We have done a new change. So the changes have been saved. Now we initialize again. Terraform init. Now you see it works well. Because it's finding the right bucket. So we have initialized our Terraform successfully. Okay. So ls Terraform plan. Let's see what we are hoping to create. So this is the plan. We want to create an EC2 instance. And also we want to apply a file, jenkins.sh. This is the file. This is our key, Jenkins key. And we have a file for user data as well, EU Central 1A. So we do our Terraform, apply. Auto approve. So our resource is being created. If you check on our AWS instance, EC2, it's like I have a cluster here in this region running. No cluster. It means I'm paying serious bills. Because I had forgotten that I had EC2 instances here running. I'm not aware of these instances. But this is the Jenkins we have created. So this EKS and master, we don't need them. Terminate. So this is our Jenkins server running. And what we expect is that the script should have run successfully So if you check, let's see if the user data script was used. So this is our user data script. So we expect that this script should have run successfully. And the only way to know that this script ran successfully, let's try to connect to this instance and see it's still initializing, meaning the script is probably still running because it's still initializing. But let's try to connect to this instance and check if the script ran. So we want to check if Jenkins is running, if Docker is running, if kubectl is running. Those are the things we're checking for. And my key is on my desktop. So I just cd into my desktop where I know my key was, and then I SSH. I'm in my instance. So if I run Docker, let's see if Docker is running. Docker is not yet running. If I run kubectl is running. If I run Terraform has been installed as well. If I run Git has been installed. So yeah, so now Docker has been installed. Do you see? Docker has finally been installed. So what is left? Jenkins, right? Sudo systemctl status Jenkins. Is Jenkins running? So Jenkins has been installed. Jenkins, Docker, Terraform, Git, kubectl are all installed in this server and they are running. So for us to know and be sure that they are running, we need to get the public IP of this instance and try to access our Jenkins server. Because remember, in our user data script, if you look in our script here, you'll see that we had opened port 22 in the security group, port 80 in the security group. So we expect just to access our Jenkins seamlessly. Port 80. Can we access our Jenkins seamlessly? Our Jenkins server has been accessed. Okay, so we copy this command to get the key and we go back to our instance. We are still connected to our EC2 instance and we run sudo cat and we paste this. We get the key to our Jenkins server and we access, we log in into Jenkins. So we installed the default plugins. So we're starting up Jenkins, our Jenkins server. Now our Jenkins configuration, while it's loading up, I'll walk you through the next steps of our Jenkins, of our configuration. If you look at the next steps, we close this Jenkins folder. Okay, Jenkins has been installed, so we forget about this directory. Okay, our Jenkins is installed, so we forget about this directory. The next important directory is this one, to build our application. To build our application, we have the package.json, we have Dockerfile. This is our Dockerfile. Our Dockerfile says our application should be exposed on port 8080. We have the images, okay? These are the images that will be on our application. This is the app.json file. We have the views. So this is the file to build our application, and we are building from this Docker file. So our application will be built from this Docker file. In our Jenkins pipeline, we also want to create an EKS cluster. To create our EKS cluster, we have this file, eks.tf. This is the module to create our EKS cluster. There are so many modules, so we want just one instance, right? We don't want to create so many EC2 instances. We want just one. We can change this to 2, okay? We want just one EC2 instance. And For the main.tf, the name of the instance will be EKS Hilltop. For the provider, AWS is our provider. For the variables, the name is EKS Hilltop. This is the version, release version. This is the CIDR block of the VPC. For the VPC configuration, these are the different subnets that we're using. So we're using 3 subnets. Availability zone. This is the module for the VPC. Okay. And one thing that is important is this. This is going to assign a public IP to our EKS cluster, to our VPC. So this configuration here is what will enable our VPC to be able to create a load balancer. The moment we deploy our application, it should create a load balancer for us. So this is the configuration file. And also important is our Jenkins file. In this Jenkins file, we are going to break it down gradually to understand the different steps. What is involved in our Jenkins file? Maybe we should start configuring. We should go back to Jenkins, and then when we get to that, we configure. So the username, Jaffa, password, I'm using a simple password, full name, and email. I just pick any of these emails. So our Jenkins server is open and ready for the first job. But before we do that, we go to Manage Jenkins, and we go to Plugins. In Plugins, we can install a number of plugins that we need. But for this project, we just need the pipeline plugin, pipeline stage view. I mean, you can install as many as you want. Timestamp. You can install Blue Ocean. This too is okay. Don't need more. For this project, this is just basically what we need. So while it's installed, the process is going on, we also need to do a few things. Now, to be able to configure our pipeline successfully, we need to put in some credentials. Very important. Some credentials, global credentials, add credentials. And we need the first type of credential, which is our Docker credentials. So it's going to be our Docker username and our Docker hub password. Now, if you look at our Jenkins pipeline, okay, where we are going to be using Docker credentials, so we have a step here for Docker push. So in Jenkins, under credential ID in our pipeline, it is called Docker, like this. So when we are creating a username and password, inside of Jenkins is going to provide 2 variables, username variable. So you see Docker username, which will be password variable, and Docker password, which will be the Docker password variable. But now in Jenkins, all we need to put is Docker. Jenkins itself will provide these other 2 for us. So the name will be Docker in capital letters. So I come back to our Jenkins server, and the username of our Docker hub, the username for my Docker account, this is my Docker account, the username is Jaffa. So in Jenkins, the username here will be Jaffa as well. And the password, I put my password for my Docker hub account. The ID now is Docker. This is the ID, right? And for description, you can just put Docker as well. But the ID must match whatsoever we have defined in our pipeline here. So this is the ID. Credentials ID. Very important. You don't mismatch this. So the ID is Docker. So this one has been created. The next set of credentials that we need to create is our AWS secret key and AWS secret access key. Now I'm going to go to my desktop and find those keys. So in my desktop, I know that on desktop, I might just also show you how to find it on your PC as well. Okay. So on your PC, if you go to this PC, local this, and you choose, and you go to users, you choose your user, you're going to see .aws. In .aws, you see credentials. So I can open with subline text. So I'll open it, I'll open this, and you don't bother about the credentials because I will delete it after. Okay, luckily I have it on a separate screen, so no worries. So back to our Jenkins server, we add new credentials, but we must name it accordingly. We don't just name it anyhow. So in our Jenkins pipeline, this is how we call it: AWS access key and AWS secret access key, like this. So AWS access key, here, the type of credentials, we are going to put secret text, okay? Secret text. And it's going to be, the secret is going, the ID is AWS access key. And the secret, I make sure that I copy it well. So I've copied the secret, I paste. Description can be the same as this. So AWS access key has been created. The next secret that we need to create is the secret access key. And this is how it is also named in our pipeline: secret access key. We change this to secret text as well. And the secret, I paste the ID. Can also paste this as well. And the secret access key, I carefully copy it. Remember, no spaces. And I paste. So our credentials are okay: AWS access key and AWS secret access key. They have all been created. We don't have a project yet. So we go to new item in Jenkins. We want to create a project. The project is Hilltop project. And we're doing a pipeline project. Okay. So our project directory has been created, and we can go on to begin. Remember, there are two strategies or more that you can use. Okay, you can put whatever project description it is that you want to implement, and you can either choose a pipeline script or a pipeline script from source code management. So if you choose a pipeline script, then this means we definitely have to copy this script. Okay, we need to copy this script and run this script from here. But what I want us to do is to run this script from our Jenkins server, from our GitHub, sorry. So I want us to run this script from our GitHub. So source code manager, which source code manager do you want to use? We want to use Git. So what is the Git repository? So I go to my Git repo and I copy the repo URL. So this is the repo URL. I copy and I paste on my Jenkins server. So it's a public repo. That's why we don't have credentials. But had it been, it's a private repo, we needed to put our GitHub credentials also as secret, and we'll use those credentials here. But since it's a public repo, that's why we don't need credentials. And now it says it's going to be checking from our master branch. Let's see if this code is in our master branch. Which branch is it? It's in our main branch, so it shouldn't be master. So we change this master to main. So it's going to be pulling from our main branch, and it's going to be pulling from a Jenkins file. Do we have a Jenkins file existing here? So your Jenkins file shouldn't be in another directory. Your Jenkins file should be in the local or current working directory, or in the root directory. So your Jenkins file should always be in the root directory. But had it been you put your Jenkins file in another folder, it means you need to provide the full path to your Jenkins file. But in our case, our Jenkins file is in a root directory. Let's look at our Jenkins file now critically. In our Jenkins file, look at how our Jenkins file is structured. So we have defined 3 environment variables, okay, which is our access key, which we have rightly put, our secret access key, which we have rightly put. Where do we want our cluster to be created? Which region? EU Central 1. That's the region we are using, right? So our region is okay. Now, look at the first step. The first step is git checkout. So we're going to be cloning this repository. Okay? So this is our first step, is a git checkout. We clone this repository. The second step, we need to make sure that the repository URL is correct. So this is the repository URL. And I think it's correct based on what we have here. It's the same repository. Now, the next step after it clones the repo is that it checks now, it defines two things, okay? It defines our repository in Docker Hub to be Java Hilltop nodejs app. Let's check if we have that repo. This is my Docker Hub account, and these are my repositories. Do we have that repo? Java Hilltop nodejs app. This is the repository. So we have this repository, right? We have this repository, and we have one, look at all. We have just one image tag, right? Called latest. Since we have just one image tag called latest, last push was a day ago. But for us to be more clear, let's change this image tag not to use latest. Let's change it to use something like new, okay? Let's change it to use something like new. So it's going to use new. And now we are going to do a Docker build. And what is this Docker build building from? It's building from this our Docker file, because this our Docker file is also in the root directory. So it's going to do a Docker build, and it was going to tag that image with our repo name and this tag new. So it's going to be Docker build Java Hilltop nodejs app :new. Then it's going to run Docker images. This is the first step. After this step is successful, the next step is going to be Docker login. So it's going to run this step with script. So with credentials, username, password is going to be username, and password is going to be the value of credential ID, which is our Docker. And in this our Docker in Jenkins, we have defined so if you go back to manage Jenkins and to credentials, we have defined our Docker, which is our ID. The ID here is Docker, and the type was username and password. So it's going to define the username and password, and it's going to do sh Docker password. So it's going to use Docker login, username, and password. So this is how we're going to log in into our Docker Hub account. After we log into our Docker Hub account, the next command is going to be Docker push. So it's going to push the image that was built here. It's going to push this image into our Docker Hub. So we're defining the image repo to be this, and the tag to be, we had used new here. So we change this as well to new. So it's going to push the new to this repo. So sh docker push this name and this tag to the repo. Then the third step now is going to be to deploy our EKS cluster. So it's going to do it's going to run a script called AWS EKS describe cluster --name hilltop EKS cluster -- query cluster status. So this script is simply going to check our AWS account if the name of this cluster exists, because this will avoid us running this script multiple times. And if you run this script when the cluster already exists, it means Terraform will try to destroy the cluster and recreate it. So since we don't want to do that often, the name of the cluster is Hilltop EKS cluster. We need to check if the name corresponds with what we have in our file. So I check the EKS. Well, where did we specify the name? EKS Hilltop. So we need to correct that script, EKS Hilltop. So the cluster name will be EKS Hilltop. Good that I checked. So we need to correct this script, EKS Hilltop. EKS Hilltop. So it's going to check if there is any cluster existing by this name. If there is a cluster existing by this name, so it will say, if it doesn't exist, it will say not found. But if it exists, it's going to do, if it doesn't, sorry, it's going to do, if the response is not found, then it's going to do sh terraform init -- migrate state. This migrate state means that if there is already a state file existing, it's going to recreate another state file. Then it's going to do Terraform plan. After Terraform plan, it's going to ask us if the plan is successful. If this Terraform plan is successful, then it's going to ask us, do you want to proceed with the EKS cluster creation? If our answer is yes, then it will be okay. It will create it. So it will do Terraform apply auto approve. Okay, then else, if we say no here, then EKS cluster already exists. It will skip the stage. It will not create the cluster. After the cluster is created, we are going to run another step, deploy to EKS. So this deploy to EKS, first thing for you to understand, which I should show you, is this directory. If you don't specify this directory, EKS, remember our EKS configuration is found here. This is where our EKS configuration is found. So you need to specify and tell Jenkins the directory where it should find all these Terraform files to create. So that's why you see it specified directory here. When we are creating the EC2 instance, the EC2 instance was found in Jenkins. So had it been we are creating this from Jenkins pipeline, we need to specify Jenkins as a directory. So for Kubernetes cluster, we are specifying the cluster directory here where it should find the Terraform configuration files. So same thing for to deploy to our EKS cluster. The directory is called deployment. So this is the directory. We have two files there. We have two files in this directory called deploy and service. So in this deploy, we simply have a deployment, and the deployment is deploying this image called, so this image will be wrong because now this image is new. So the image that will be created will have a tag new, not latest. And this is the service. The service is the load balancer type of service. So this is what will create a load balancer in our AWS account. So back to the Jenkins file. In the Jenkins file, there are changes that we did not commit the changes, so we need to do it back. We need to change it back to new. New. And we also need to change it here to new. Our image tag has to be new. And the cluster is EKS Hilltop. So here it's going to use, remember how we define. So in this step to deploy, we need to put with credentials. Same thing we did for Docker. For it to be able to log into our Docker account, we use with credentials. And the way we specify our credential was we use Docker because it was username and password. But here we created two separate credentials. So with credentials, credential ID here is AWS access key. So we are going to give it a variable name called AWS access key ID. But what we created was AWS access key. And the second credential is AWS secret access key. And the variable will be AWS secret access key. So it's going to do sh EKS AWS EKS update kubeconfig -name EKS hilltop. And sh kubectl apply deployment kubectl apply service. And it's going to be running this inside this folder called deployment. That's where it's going to find these two files. When the step has run successfully, then we can then run this last step to destroy the cluster. Terraform destroy auto approve. So for us to do this, the first thing we need to do is we need to, let me see where this file closes. This step closes here. So I want to comment some sections. So to comment a section so that it doesn't run, this is how we comment. So I've commented out this section. I don't want this section of the script to run all of this until here. So we are going to do it one step at a time. So let's start from Docker git clone, okay? We're going to start from git clone. Git clone stage. Let me see where this closes here.
Well, I did not really pick how we comment.
This is it. This is how we comment in a Jenkins file. Like this. This is star. This closes the comment. To open the comment, I'm looking for where we should start commenting. After git clone, I think it should be here. So to comment, this is how you comment. So I put /star and I close it with // okay? /star and //. So I commit these changes. So I've committed the changes. So all this code from here, if you see that the color is different. All this code from here, no, I should comment this one down here. This should be commented down. Let me see. Stage. Yep. Commit changes. Yes, it's commented. Yeah, this is commented. So all of these changes have been commented. So when the Terraform script is running, when Jenkins file is running, sorry, it will run one step, and that one step will be the git clone. Are you seeing? It will only run the git clone because I want us to go progressively and build the pipeline progressively so that all does not run at once. So if I come to Jenkins and we're using main from our Jenkins file, so I save the changes. So let's build now. Let's build and see. We are expecting just git clone to run, right? So build now. Okay. So it has run successfully. Our git clone has run successfully. So if you go to console output, you see this is it, finished, success. Git clone was a success. It has cloned the repository. If you want to see that, if you go to our instance here, where it is running, we do ls. If you cd into var lib Jenkins, let me see, ls, var lib Jenkins, fingerprint Hudson, jobs, I hope it's jobs. cd into jobs, ls. Yeah, this is the project, right? You see the project. cd into hilltop project. This is the project, ls. You're going to see the build. cd into build, ls, config.xml. Let me see, update user context, workspace, or should it be workspace? cd into var lib Jenkins workspace ls hilltop project, cd into hilltop project. Can you see? Can you see the file that we just cloned? This is the file that we just cloned. This is our Docker file. This is our deployment. Okay, this is our Jenkins for our EKS for Terraform files. So all the file that we just cloned is here now in our Jenkins server. I'm doing this from the command line. But if you go back to the Jenkins server, or let's go back to our GitHub. Now, the git clone is successful. Let's move this comment down here to this step, okay? Let's comment it at the next step. So we're simply moving this comment to this point. So it's a /star, and I remove it from here. So what is the next step we're expecting? We're expecting it to do a Docker build, right? We expect a Docker build to take place in the next step. So I commit these changes. back to our Jenkins server, and I go to the project. Let's do a Docker build. Let's do the next step. It's building image, right? So we have a Docker build taking place. So the Docker build has been successful. The build is successful. If you go to the console output, this is it. Our Docker build phase, Docker build -stack heat-up consult, Java heat-up nodejs app new. So it has been built successfully from our Docker file. If you go to the cluster, to the server, if you do Docker images, can we see the image that has been built? This is the image, right? The image has been built successfully. So we have this image running. So the second step is successful. Let's go to the third step. The third step in our configuration in our Jenkins file is that we want to do a Docker login. Okay, we want to do a Docker login. So we need to try and see if our login is going to be successful. And to do that, we do the same thing and we take out the comment from here. We want to log into our Docker Hub account using those credentials that we put. And for it to log in, remember we have put our Docker credentials. So I go to build now. So the build should be faster, hopefully, because it's our login is successful. So this first build took how many seconds? 9 seconds. But look at how long the second build is taking. The second build took just 1 second, and the login is successful. This is successful because our build here built everything with the first layer. But in the second, it will say that it already exists. So if you look at the console output, it will say layer already exists, console output. Now when it's building, if you look at when it's building here, for the Docker build here, all the layers already exist, okay? All these layers already exist. That's why the build took a shorter time, because all the layers for the Docker build already exist. So it took a shorter time to do the build. So when it did the build, it logged in successfully to our Docker Hub account. So the login has been successful. Now, after it has logged in, we need to push the image that has been built to this Docker account. And to push, we can simply on comment. Where is our comment? Why am I not? Okay, this is our comment. So from here, we need to remove this comment and do a Docker push. Okay, we need to do a Docker push. So I remove this comment. From here, I commit the changes. Our comment has been moved. Now, if you look at our Docker Hub account, this is the repository that we are using. And in this repository, we have only one tag called latest. So the new tag we expect should be new. The name of the tag should be new. The value of the tag should be new. So we come back here in our Jenkins pipeline and we run a Docker, the next step, and we expect it to push the image. Cloning again, checkout, build, pushing. Are you seeing? Our image is being pushed to our Docker Hub. Is the push successful? The image push is successful to our Docker Hub. So let's verify if we have a new image. So I refresh Docker Hub. Do we have a new image? We have a new image with the tag new. When was it pushed? A few seconds ago. So we have a new image in our Docker repository. That stage is successful. The next step now, according to our configuration, we have this image being pushed. The next step is now a big step to create an EKS cluster. Okay, this is the big step, and this is the Ngumba house. To create an EKS cluster, these are the steps. The directory is going to check if an EKS cluster exists with this name. It's going to skip the step. But if it doesn't, inside this directory called EKS, this is the directory called EKS, it's going to create us a cluster with Terraform in it and Terraform plan. Now, one thing that we need to change in this EKS configuration, if I'm not mistaken, but before this, let's uncomment this EKS cluster creation step. Okay, and put it here. So we are commenting the deploy to EKS. So now we need to create an EKS cluster. But one thing we need to make sure of is that in this EKS cluster creation step, the region is properly defined. I mean, the bucket, because we define a Terraform state file. Let's see if the backend, our backend is configured well. Otherwise, this might fail. Created by EKS. Let's look at provider. Where did we have our backend? Version release, VPC. Do we define a backend? If we don't define the backend, then it means it's going to use our local as backend. Modules, VPC, variables, provider, main, EKS hilltop, the EKS configuration, cluster name, T2 medium. So we're using an instance of T2 medium. So we're not defining any backend, right? So it's going to use local as our backend. It's going to use local as a backend. So it's going to create a backend locally on the Jenkins server. So I just needed to make sure of that. So now we want an EKS cluster to be created. So I do build now. Before it's created, if this script works successfully, it should prompt us if we want to create an EKS cluster or not, for us to manually say yes. Are you seeing? Create an EKS cluster. We expect it to ask us if everything is okay. Can you see? It says pause for 4 seconds. Can you see? Do you want to proceed with EKS cluster creation? Is this what we want? I say yes. So if you look at the script now, the logs, console output, it has done Terraform plan, and it has begun creating our EKS cluster. In our AWS account, if we check EKS service in this region, Frankfurt, in no time, it should indicate that a cluster is in the process of creation. Can you see? EKS hilltop unknown. EKS hilltop. So a cluster is in the process of creating. So creating a cluster generally takes about 10 minutes. Okay, so this is 1 minute. It generally takes about 10 minutes for a cluster to get created. But this is our configuration, our Jenkins file. So we see that after this cluster is created successfully, because it ran Terraform in it and also Terraform plan, and we accepted yes. As we accepted yes, it went to Terraform apply. So the cluster is in the process of creation. Once this cluster is created, we are going to use these same credentials, and we run AWS EKS update kubeconfig, EKS hilltop, and we do kubectl apply to these 2 files to apply. Once it's applied, we are going to access our application on the server. So Okay, it took about 30 minutes averagely for the EKS cluster to be completely created. And if you check the logs, of course, it shows success. But if you check the logs, creating an EKS cluster takes a while. So many integrated services for the cluster to be created. So it's finished and it's created successfully. On our AWS, you can see our cluster in creation state. If I refresh, it is in active state. These are the details about the cluster. Compute. In the compute session, you see this is the node group. In our node group, we have just one node running, one EC2 instance running of type T2 medium. So if you check the EC2 session, we should be able to see two EC2 instances now running. One is our Jenkins server, and one is the Kubernetes cluster, which is running. So our EKS cluster is running in our region, which is EU Central 1. It's running well in our region, which is EU Central 1. And we can deploy resources to this cluster. So if you look at the ports, these are the existing ports, the kubeproxy, core DNS, stateful set, core DNS, deployment, core DNS, daemon set, kubeproxy, and AWS node. Okay. So this is the node that we have running, T2 medium. This is our node that we have created. Now, to be able to deploy application to this cluster, what we need to do is to update the kubeconfig file. Okay. That's how we authenticate to this cluster. How do we authenticate to this cluster? This is the access method. We authenticate to this cluster using config map, authentication mode, configuration mode, config map, or IAM access entries. Okay, so we need to authenticate. These are the different authentication methods. Either use a config map, IAM access entries, port identity association, OIDC. This OIDC is like a provider, a third-party provider like Okta, or you use the AWS Identity Center to be able to authenticate to this cluster. So for us to do that, we go back to our file. Now our cluster has been created. What we need to do now is we need to make sure that we skip this step of creating the cluster. Okay. So everything can be deployed and then we skip this step. Our cluster has been created. So for us to skip this step, we simply do this. And this step for creating the cluster will be skipped because the cluster has already been created. So we just need to deploy to the cluster now. And for us to deploy to the cluster, let's skip this step as well. So we need to comment out this step. And to comment out this step is /star. So we are commenting this last step to destroy the cluster, because if we don't comment this step, it will destroy the cluster. So we need to uncomment this one. And to uncomment this one, this was commented here. And uncomment, so we need to uncomment this. We need to put the // This was // yeah. So we want this step to run. So these are the sequence of steps. After it does a push to our Docker, it will skip the EKS creation because the cluster has already been created. When it skips it, it will run kubectl apply. When it runs kubectl apply, it will also skip this one, the destroy. Because if we don't skip this, it's going to destroy our cluster. So we're skipping 1 and 2. We're skipping create cluster and we're skipping destroy cluster. We just want to apply now to the cluster. To be able to apply, look at the Jenkins file. We are running that step in this file, this deployment file. And in this deployment file, we have two configurations. We can see that better here. This is the deployment folder. We have deploy.yaml is pulling our image. I changed this configuration from latest to new, so it's updated in our GitHub. And then the service is type load balancer. Before we even do that, check on our AWS instance. If you go to EC2, let's see if we have any load balancer running. Do we have any load balancer? We don't have any load balancer running. After creating this step, let's see what happens. So we have commented out these two stages. Let's commit our changes. Our changes have been committed. So the creation, EKS cluster creation has been commented. Likewise, the EKS destroy has been commented. So we go back to our Jenkins pipeline. It's going to be faster now because we are not creating the cluster. It's going to skip that step. We already have our cluster running. Back to project. It took 13 minutes. We do another build. This time around, we won't see this phase. It will skip this phase because it has been commented. But of course, we know the cluster is already existing. So it's building our image. When it's done building, it's going to log into our Docker Hub, push the image to Docker Hub, and then when it pushes, we expect a Kubernetes deployment and not to see create EKS cluster. So this pipeline is going to skip this phase. It's pushing our image. And remember, create EKS cluster has been commented. So it's going to skip that phase and we'll have something else here. Are you seeing? It's doing deploy to EKS. Has it been deployed to EKS successfully? Our pipeline has deployed to EKS. We can check this to see. On our cluster, which on our EC2 instance, remember it has already done kubectl update kubeconfig file, okay? You remember if you run kubectl, we have kubectl running. So if I do kubectl get ports, error, server doesn't have resource port. So we need to run the EKS update kubeconfig here also to be able to get it. So let's see. Yeah, we need to run AWS EKS update kubeconfig here to be able to see it locally. But let's see on our AWS server if a load balancer has been created. Our service is of type load balancer. Has a load balancer been created? A load balancer has been created. Now we need to access our application using this load balancer. Let's try to see if we can access our application using this load balancer because this is the load balancer DNS name. This DNS name. This is how we access our application. So I copy this DNS name and I paste on our browser. Are we getting a response from our application? There's no response from our application. Something is probably wrong. Okay, now we can access our application. I thought it was a security group issue, but we can access our application. This is our application being accessed from our load balancer. Can you see? We're able to access our application from our load balancer. So this is the load balancer that has been deployed on AWS. You copy the load balancer DNS name and you can access your application seamlessly. Okay. Is the project deployed end-to-end? So we have had a successful deployment of our application end-to-end. So I'm going to drop the link to this repository so you can clone or fork this repository, follow the steps as is described to create your own cluster and deploy your application. And I'll explain better so that you see the codes from the VS Code. So if you look at our configuration, I'm taking the steps all over again as a summary. This repository is found in our GitHub. It's a public repo, so you can clone the repo. When you clone the repo, you have the Jenkins folder. In this directory, you have the VPC configuration, variable, Terraform, all of these Terraform files. And most especially, you have this jenkins.sh file. This bash shell script simply updates the cluster, the instance that is going to be created from the Terraform files, and it installs Jenkins with Java, it installs Git, it installs Terraform, it installs kubectl, and it also installs Docker. And what you can do is the region of your choice. If you want to use this script, you make sure that you select your own region of choice. Here we are using EU Central 1, and also your key pair, okay? Your bucket, you create your bucket, you must create your bucket as well as a prerequisite. So you can create, if you want to use the same script, in the same region, you create a bucket with this same name. Another important thing is the key pair. So the key pair that I use is called Jenkins key. My key pair is called Jenkins key. Port 8080 is open for our Jenkins server, and my key pair is called Jenkins key. Let me see where that key is specified. Yeah, this is the key in the Terraform TFVAS Jenkins key. This is the instance type, and this is the tag env prefix prot. So I'm using Jenkins key. So as a prerequisite, you must also create this key pair Jenkins key with this name, or you modify it if you have an existing key. So you do this, you run this script locally, and you create this Terraform configuration. Once this Terraform configuration is created, you copy the public IP address that will be produced from this Jenkins server, and you open it on port 8080. Once you access Jenkins and configure your Jenkins browser, and you create a pipeline, you're now using the Jenkins file. Within the Jenkins file, what I have defined is my AWS access key and secret access key. And this access key and secret access key are my root credentials. So you make sure you put your own secret key and secret access key. Whatever region you decide to create your cluster, you make sure you put that region, you define that region here. I'm using EU Central 1. If you have changed the name of your repository, or if you're maintaining this repository, you make sure you put the name of the repo. If you're using your own personal repo, if you use mine, then you maintain this repo. And for Docker, you make sure that you also create your Docker Hub account, and you create the repository. So this is the name of my Docker account, and this is the name of the repository. Okay. This is the name of my Docker, and this is the name of the repository. And this is the tag I am using latest. You can change this to new whatsoever v1, and you do a push to your repository. To be able to push to your Docker Hub account in Jenkins, you create a secret called Docker. And within that secret, you choose the type, username, and password. You put your Docker username and your password. You make sure that you've checked and they are correct. And then you push to that repository. After you push to the repository, the next step, this was commented. After you push to that repository, the next step will be to create your EKS cluster. So to create the EKS cluster, you simply make sure you specify this directory called EKS. That is where the EKS configuration is found. So this is the directory for the EKS configuration. You create your EKS cluster. You can modify the cluster based on what you desire. I'm using just one EC2 instance of T2 medium. So you can modify yours as well, depending on your requirements. And this is my cluster name, EKS Hilltop. You can modify yours based on your requirements also. And for my variables, the name of the cluster, the CIDR range, you can modify the CIDR range based on your requirement as well. And I'm enabling the possibility to create a load balancer for my cluster. So you do that based on your requirement, what you want to use in your environment. So on the Jenkins file, you run your EKS Terraform apply. Your Terraform apply is going to create your EKS cluster. And after your EKS cluster is created, you then authenticate to the EKS cluster by passing your secret key, secret access key that was put in credentials in Jenkins, and then you run AWS EKS update kubeconfig, then the name of your EKS cluster, then you run kubectl apply in this directory, the deploy and the service, to deploy these two applications. So you must remember that in this directory or in this deploy, you put the name of your image and your repository. So if you don't use this, it won't work. You must make sure you put the appropriate name of your repository, the name of your account, the repository, and the image tag, and the required port for the application. And if all of that works successfully and well enough, then you should be able to access your application on the browser as such. So this is our application. We can access this application on our browser, okay? You can access this application on your browser. So thank you very much, and I will take questions. Any questions?